Your workshop, an easy backend for your application, part of our Cloud Native Cassandra series. I'm David Jones-Gilardi. I'm joined today by Erick ZIETLOW. Hey, Erick.
Hello, how you doing today, David?
Doing all right. All right, let's go ahead and make us a little smaller. So, hello, everybody. And just to kind of give you a start into what to expect. So today, this is actually part of a multi-episodic series, if you will. But we're starting with the first one, an easy backend for your application. So really what we're going to focus on here today are the backend CRUD operations that you would need and use to work with a Cassandra database. Now, as we go into the other parts, now, by the way, I just want to point out that each one of these, right, it's part of a series, yes, but you don't, let's say you're not here today, which you wouldn't know because you wouldn't be on here, but let's say that you didn't go to the second one and you're like, oh, but can I go to the third one? Totally. Each one of these is its own set of information. You can go to each one individually. We highly encourage you to check all these out. Make sure to register for each week. So in the second week, we will be talking about connecting Kubernetes and Apache Cassandra. That's where we'll take an app, deploy it in Kubernetes, and then hook that up to Cassandra, right? And then in the third week, we take that and we move it up a level, and we actually deploy to the cloud and GKE with Kubernetes and Cassandra again, right? So each one of them is going to have a different tidbit of information. Again, today, we're going to focus on just the backend application and the CRUD operations, like how do you hook it up? How do you then, get all the plumbing going? How do you get the CRUD operations going? And what all that looks like.
Yeah, taking it one layer deeper every week.
Yeah, pretty much, right? Okay, then just some housekeeping, right? So if you take a look over on the top left-hand side, you'll see our YouTube channel, DataStax Devs. Now, most of you are probably watching us right there, so you probably already have that. That's wonderful. If you haven't already, though, subscribe, click the bell. That way you can get notifications when we have workshops going. If you've not been with us before, you'll find that we usually have at least a workshop every week. We have Learning Mondays. We have all sorts of things that are going on. So if you want to be able to keep up to date with what's going on there, then you definitely want to go ahead and subscribe. I should also mention, for those of you who have been with us before, you've gone to the YouTube channel, admittedly, things were a little unorganized for a time. Pretty much all the videos from all the workshops that we had were just out there. We have gone through, we've got new graphics, we have reorganized everything. The videos have been consolidated. It should be a much easier experience now to find what you're looking for. So if you haven't in a while, go take another look. Now, looking over at the top right-hand corner there, you'll see that datastax.io/workshop. That is going to be for our Astra DB. Now, I was watching the chats earlier. It looks like a bunch of you are already registering and getting your databases going. That's wonderful. Astra DB is going to be the Cassandra database that we're going to use today. What we're going to use today is a free tier, right? We're going to talk more about that in a second, but it's a fully managed Cassandra cluster. It only takes a minute to spin it up. So that's what we're going to use for our exercises today. And you're not limited to just using it for what we're doing today. You can use this for your applications, for whatever you're looking for as well. On the bottom left-hand corner, you'll see that bit.ly to Cassandra Workshop. Now that's bringing you to our Discord channel. Some of you are already there chatting with us today. And that's wonderful. So I'm glad that you found that. Now, you can chat with us on the YouTube channel, and that's perfectly fine. We're actually going to maintain both, right? We're going to be trying to answer as many questions and interact with you through both YouTube and Discord. The big difference, though, is that when the YouTube stream stops, the YouTube chat stops. If you want to be able to have, say, a more in-depth conversation, you want to be able to talk to us after the fact, that's where the Discord channel comes in. There's also something like 7,000 other folks in the Cassandra community that are with us there in the Discord channel. So then you'll be kind of joining that community as well. So again, we encourage you to join our Discord if you haven't already. It's a great resource to use, especially if you want to be able to talk to us after the stream today.
Absolutely.
All right, so disclaimer. This is kind of a disclaimer, not totally a disclaimer, but this is really, it is a coding session today. Now, the disclaimer is this, and I've already seen some questions about this. We are going to be using Node.js and Python for the code. But if you're not familiar with any of these, while it's good that you do have some familiarity, you don't have to. The exercises today, I think they are for any level at the beginner level. They're going to be pretty easy. Really what we're doing is we've implemented the CRUD code and stuff that you need, right? This is really going to be more of an exercise of running certain operations and then being able to reference that for your own use later. So let's say that you're a Node.js dev and you're like, you know something, I really want to know how I can use paging or how I can insert. That's what this app is for. It's perfect to then go, oh, okay, here's this one class right in there. I have everything I need, a very nice, small working example, right, of how to do whatever that particular operation is. So we're providing this stuff for you. That's really what I'm getting at. So don't worry about the disclaimer so much. Another piece is that all of the code that we're doing is through Gitpod. So you will need a GitHub account for that. If you want to do it locally, you can, but any kind of issues you run into, it's kind of on you, right? We have pre-configured everything in Gitpod. And if you've not used Gitpod yet, for those of you using GitHub, you might have noticed that little Gitpod link that showed up, like, I want to say like the halfway through last year or something like that. Yeah. It is a wonderful free resource that gives you a cloud-based IDE that you can just spin up right out of your code, right? You can share it with coworkers and everything. We love it. It's been a great resource for us. What we've done is we have pre-configured everything and preloaded things like, npm, pip, all that stuff has all been preloaded for you. All you need to do is spin it up. Again, that'll be in the exercises, and you're good to go, right? So anyway, we really encourage you all to use Gitpod. You will need a GitHub login for that. I think most people do have that. But otherwise, you don't really have to install anything. Everything that we're going to do will be provided for you up in the cloud.
Awesome.
Okay, so with that, for the hands-on, we will have some hands-on today, right? If you haven't done this already, we should drop some links, Eric, in this. Go to... Yeah, thank you. Are you doing it? Awesome. Yeah, so the first one's going to be, again, I mentioned that datastacks.io/workshop. Notice the QR code there on the top right. You can just scan that with your phone. It'll bring you to the registration for Astra if you haven't done it yet. And then on the bottom there, you'll see the GitHub repository that we are using today. Again, we have the QR code. And let me just go ahead and check. Okay, and I see some questions coming in and everything. I'm just kind of making sure I'm up to date on all the stuff that's going on.
Yep, we should be good. I've been watching it as well.
Wonderful, and Eric's dropped the link there. Good, okay, excellent, excellent.
One right now.
All righty, and let's do that. All right, with that, let's go ahead and take a look at what we're going to talk about, right? So in the 2 hours that we have, so the first thing we're going to do is we're going to start off with our use case and the data model. Now, we haven't really talked about the app that we're using today. It's a spaceship app, right? So the app is kind of really there to help you explore CRUD operations in the back end. The front end of it and what it's doing, I don't think is as important. But what we're going to be working with is...
We're just going to do the CRUD. We're getting our hands dirty.
Yeah, exactly. But the app itself, what it's really doing is, imagine you've created an app that's going to track spaceships on their journeys. Right. So as a spaceship, whether it's something from SpaceX or NASA or whatever like it, or whoever other company, it launches, then for each spacecraft and that particular journey, we want to record some information about that. There's also sensor readings, things like the speed, the temperature, pressure, all sorts of things. So this app really is just designed to kind of visually show you the data, the types of information that's coming from the sensors, and then storing that in the back end. So we're going to use this use case and use that to generate our data model that we're then going to apply to our Cassandra database with our schema. Then we're going to connect up the app. It's actually really, really easy to do. We'll show you how. So we're going to hook up the plumbing and get the plumbing from the app going to your particular database. And then the CRUD operations come into play. If you're not familiar with CRUD, right, that's create, read, update, delete. Those are just the basic set of operations that pretty much any application needs to do with its database. So once we get to sections 4 and 5, we're going to start working with creating data, updating record, reading the results. How do I parse them? How do I page? All that kind of thing. Okay, so as we mentioned, this is really more focused on the back end. Even though the app we're working with today does in fact have a front end and such, we're not working with that part of it. But I just wanted to show you what that looks like. Again, you could tell that this part of it is really meant as just a demonstration platform to kind of demonstrate what's going on in the back end. That's really what's happening. But as you start a journey, there are various sensors that are, there's information being generated, things like temperature, speed, pressure, location, all that data. If you imagine, you're not just going to have, say, one measurement at speed for the whole journey from wherever you start to wherever you end up. There's going to be many of those at each different time step, right? So there's all this underlying kind of information that needs to be stored in our database, and we need to retrieve it later. So that's what we're going to do with the backend piece. So again, I'm just showing this to you so you kind of have a little bit of context of what it's doing, but the front end isn't really all that important as we launch. Okay, here's where this stuff gets fun and important. So in Cassandra, and I already saw some folks asking about this earlier in the Discord chat. One in particular was saying, hey, I'm new to databases. I didn't come from the relational world. Am I going to be okay? And I'm like, you're probably going to be in a better place. For those of you coming from the relational world, like many of us, there's a set way that we've kind of been doing things for a long time. Now, Cassandra isn't that much different. We still have a required schema. We're going to create our tables in a schema just like it would in the relational world. The difference is in the how. So in Cassandra, we're actually going to use our queries. We're going to use our application workflow and the queries that we generate from that to generate our data model. That's a little bit different from how we might do it in the relational world. What I want you to focus on here is the first two things you see on the left-hand side, the conceptual data model and the application workflow. So anybody who's, generally speaking, if you've been doing any kind of coding or database work at all, you're probably familiar with the conceptual data model. We're going to look at one in a moment. But you're going to take that and the application workflows. So imagine any application at all. The vast majority of e-commerce applications are going to have some kind of user tracking. It doesn't even have to be e-commerce. The vast majority of applications do. Well, the second you know that you're going to have, say, a user function and a user login function, you're already starting to map out some of what that application workflow looks like, right? Oh, I need to log in for a user. I need security for the user. I need to store information about the user. All these types of things start to generate like pseudo queries, if you will, right? Now, we're not going to be going down the user path here. I'm just giving that as an example. But you'll find that as you ask the questions from your app, what types of things does it need to do? You are already starting to write your queries. You just might not know it yet. So we're going to go through that process, right? So again, we're going to start with the conceptual data model with our application workflows. Then we're actually going to use that to start generating our logical data model. Right? This is where we start to look at the pseudo tables, like, okay, what tables might I need? What fields maybe do they need? What keys do I need, right? Then once we've kind of broken that down, we'll then move that to a physical data model. So what kind of, field types do I need, right? And honestly, going from logical to physical isn't that hard. It's actually just going, one's defining what the structure is going to look like, the other one's defining what the types are, and then you implement with your CQL. So if you haven't done this before, we're going to break it down. We're going to go through it. So don't worry there. And some of the resources we are going to send you to as well will really break it down even more. Okay, so
I will point out here that starting with the application workflow is actually, in one sense, a more logical way to do things, because you're eliminating from the thought process all the post-processing of the data, because you're starting to store your data in the way you want it retrieved. So it's actually super, super efficient to do things this way. You're just going to end up with redundant data due to denormalization. So if you start to kind of do the mind shift this direction from maybe a more traditional, third normal form or something like that, you actually will experience, even in the relational world, you experience gains for doing it this way. It's actually pretty cool. You're exchanging storage for cleaner IOPS, essentially, is what it boils down to.
Yeah, and by the way, I see Shubham Kumar on YouTube says, some are very new to this. Please explain big words. Very good point. Yeah. This session will be 2 hours, Niraj. So as far as like some of the things that Eric just mentioned there, right? And I guess we should just give a little explanation about Cassandra. Right. So
I can dive into that if you want, or
either way, we'll go back and forth. Right. So Cassandra is a distributed NoSQL database. Right. The core tenets are its ability to perform at scale. And when I say perform, we're talking about maintaining like tight single digit, tens of millis response time and reads, no matter the scale. A Cassandra database could be a couple of nodes. It could be thousands of nodes, right? It could be petabytes of data. And it does this while also maintaining robustness. It's known to be an extremely robust database. You can lose big percentages of the database and it's still available to handle requests and such. Some examples, Netflix. Uber, Sony PlayStation, right? Apple, the stuff from Siri and such. Most of the banks and credit cards. Yeah, what else you have, Eric?
Yeah, Twitter is definitely one.
Twitter, Instagram, Spotify.
Yeah.
Yeah, so
basically anything that uses any sort of scale is probably using Cassandra somewhere, because it really is the only thing out there that scales linearly. NoSQL obviously is a large grouping of a ton of different database technologies. I've seen a lot of people in chat mentioning like Couch, Mongo, different things. But those have limits to how far, either they're using a sharding technology that's limiting, or there's some sort of a primary, secondary relationship, master-slave relationship for, the more legacy terms. But Cassandra gets around all of that by not even approaching things from that angle. It starts basically trying to handle things in a pure relationship using distributed hash maps. So we're not going to get into the architecture of that today, but it really is powerful. You get 100% of the value of the node you're adding to the cluster at 1,000 nodes, the same as you would at adding it at, like 10 nodes. That same 100% value of that new node is there. So you can just keep scaling and scaling and scaling until your network is completely saturated, and then you have to upscale your network, right? It's really cool what you can actually accomplish with this.
Yeah, and so, by the way, to be clear, a lot of the stuff that we were just talking about is not stuff that you need to worry about today. Matter of fact, that's where Astra comes into play. So we'll talk a little bit more about Astra in a second, but Astra is fully managed for you, so you don't have to worry about some of those underlying details. What it really boils down to, though, Cassandra is a database that was purpose-built to be able to scale horizontally indefinitely, to be able to maintain 100% uptime, right? Whether it's upgrades or whether there's outages, it's actually built to handle outages, right? Because it's built on the idea that no matter what network you're on, no matter what system you're on, if it's on-prem, if it's in the cloud, something somewhere is going to fail. And so you need to have a database that can handle that kind of thing. And it's also built to inherently replicate. So no matter where, you could have a completely global database, and no matter where it is in the world, if I I create or I insert some data over on the West Coast of the Americas, right? Well, if I've got other parts of my database that are, say, in China and Australia and stuff, that data will automatically be replicated out. And it's this kind of combination of things. I'm really kind of glossing over a lot, but it's this combination of things that makes Cassandra so powerful and makes it so these companies that we're talking about use it, right? And they use it for their mission critical type operations. Okay, so with that, now, by the way, I know that some of you have questions on relational comparisons. Keep asking them. Again, we will have a ton of resources that we're going to send to you. If we don't get to some of the questions today, we have resources that we'll send you that's going to help really build this knowledge up instead of us trying to dump it all on you in 20 minutes or something. Okay, so let's go through designing your data model and what that looks like. Like I said, we're going to start with the conceptual data model. There we go. All right, so if you've ever, again, worked with, an entity diagram or something, this should look familiar to you. But if you haven't, let's go ahead and take a look. Let's break down what we've got going on here, right? So remember, we mentioned that in this application, we're going to be tracking spacecraft journeys and some of the metrics that come with that. So take a look at the left-hand side. You'll see I have a journey entity there, right? So we know that that's like the basic thing we're going to start with is, okay, I have a journey and I need to record something about a particular journey. So what kind of properties might a journey have? Well, if I'm tracking journeys for a spacecraft, I probably have a spacecraft property. I probably want to know when it starts and when it ends, maybe some unique identifier with a UID. Is it active or not? Is it in progress right now, or is it already ended? And then maybe get some kind of summary. If you take a look on the right-hand side, you'll see reading speed, reading temperature, and so on. These are our sensors, right? Now, if you imagine, as I have a journey of a spacecraft, again, it's not just going to be a single speed reading or a single temperature reading. I'm going to have readings at time steps as that journey is going on. So you'll see that in each of these, there are properties like reading time, right? So I'm going to be taking readings probably multiple times a second, right? Depending on what kind of sensor it is or something like that, and storing those. And then each of those is going to store whatever that value is, and then we'll store the units, right? So that's where you see the properties, that reading time, read, and unit. Now, the other thing I want to point out is notice next to journey, right to the right of it, there's a 1. And then if you look at the sensor metrics there, reading speed, temperature, and so on and so forth, you see that 0 to n. What we're saying here is there is a one-to-many relationship between a journey and, say, reading speed. So that says I could, for any one journey, I could have 0 or n number of reading speeds. That's what we're saying there. So we've already identified a lot of information, right? We've marked out multiple entities. We have properties for those, and then we're marking out what is the relationship between these particular entities. Now, let's take that over to our application workflows. Now, like I mentioned before, the application workflows are really about starting to generate the types of things that I need to, say, look up or create, or the interaction I have with my application and the database, like the kind of questions my application is going to want. This is where I actually start generating my pseudo queries. So what do I mean? So take a look at that first bullet where it says spacecraft's catalog queries, right? Look under that. Well, for any particular spacecraft journey, I probably want to have the ability to look up all of the journeys of a spacecraft. Because if you think about it, I might have like a Falcon X rocket, right? That can have more than one journey. So a single spacecraft may have multiple journeys, and I want to be able to look them up. Or I want to look up the state of a journey. Is it currently active? Is it done? Whatever. Or I want to create a new journey. Now, if you think about the way these read, create a new journey, what is that? That's probably an insert statement, right? Or maybe an update. I'm putting something into the database. The lookups are probably reads. So you can kind of start to see where I'm working out these pseudo queries, like the kind of queries I might need to then create my tables moving on. If you look at that second bullet, that sensor reading queries, again, these are our speed, pressure, temperature, and location. I most likely want to save a bunch of those over time, right? Because for each of those time steps, I'm going to be saving the sensor readings. That probably sounds, again, like an insert or an update, depending on what you're doing. I want to be able to analyze each dimension independently, right? So it's saying I want to be able to look just at speed or just at pressure, just at temperature. So all of this is starting to kind of inform what my data model is going to look like. Now let me take a look. I want to see if how are we doing with questions?
Looks like the guys are mostly on top of it here.
Okay.
There's a lot of questions as to how things compare to other NoSQL databases,
Okay.
which most of those are being answered. I will just throw this out there. Cassandra is taking a lot of the best concepts from the NoSQL movement and applying them wholeheartedly. So I saw one earlier that said, so Cassandra is basically the best of NoSQL, graph, and SQL. Kind of yes, kind of no. It's not really a graph database. There's no joins. Basically, it's taken everything back a step from before we needed joins to actually accomplish things and said, in a perfect world, how do we do things? And then built up the database from there. So that's why we denormalize. That's why we actually work with Cassandra the way we work with it. So yeah, it uses rows and columns. Things are distributed over partitions. It's active everywhere. So globally distributed databases. You can read and write from any location at the same time concurrently. Yeah, there's a lot of different capabilities that are unique to Cassandra that just simply are incredibly empowering when you actually learn how to use them. So
yeah, and there's I see Malcolm, the IoT tryhard me is so excited. Yes, this is definitely an IoT use case. That's very funny. I see Shetan in Discord says, but if it's about fault tolerance, then why go for a managed service at all? Great question. I was actually gonna say something about that here in a moment, but since you asked the question, if you think about it, yeah, the fault tolerance is there. That's not a problem. But the difference is between, do you want to manage your own Cassandra cluster completely on your own and all of the IT that's needed with that and such, or in this case with Astra, it's being managed for you, right? Not only is it being managed for you, but DataStax, we've been in the Cassandra world since the beginning. We are the experts. I'm not saying we're the only experts. I want to make that very clear, but we definitely have our time, and we've written most of the code, right? So with that, we also have a lot of experience of running clusters in production environments. And so what we've done is we've taken that experience and that knowledge, and that's baked into how Astra works. So you'll find that a lot of the base default, say, parameters, all the configuration parameters, all that stuff is being essentially built for you. If you manage your own, you could totally do that, but then you have to figure those things out and find those yourself. So that's the big difference between the manage and not manage. And in the managed case, we're doing it for you. In the not managed stuff, you have to do it. That's really what it comes into.
Yeah, absolutely. And I will throw this out there. Back when we would set up Cassandra and we download the tarballs and set up our VMs with our nodes and all that stuff for these sorts of sessions, we'd spend about half the day setting up everything. Right now, we have 2 hours.
Yeah.
So from a self-service perspective, for today, when you can just click a button, have it
And
there,
go.
you can start doing operations, data in, data out, seeing how this whole thing works. There's a lot of value there for today. So definitely go ahead, sign up for that Astra account if you haven't already. It's free. We aren't charging you. We aren't asking for a credit card, nothing like that. Just go ahead and sign up.
Okay, so now moving from where we were just a second ago. So what I want you to do is take the conceptual data model, what we've done here, take the questions we're asking ourselves in the application workflow, these pseudo queries. Now we want to start to map that to some tables, right? I'm going to call them pseudo tables because we haven't really worked them out yet. We're just getting a feel. Now, here's what I want to point out. Notice on the left-hand side, we have our spacecraft journey catalog. And then on the right-hand side, we have our temperature, location, speed, and pressure. We have our sensor metrics again. What does that look like? It looks a lot like our entities, what we were doing over here in the conceptual data model, right? That's a really good place to start. Once you start mapping this out, then you're like, okay, I've got some pseudo tables. I know that I want to record my spacecraft journeys, and I also want to record my sensor metrics. So let's go ahead and create tables that will start to facilitate that. Now you might ask, well, why are you creating a separate table for each one of the sensor metrics? Why can't you just store them in one, right? You could, looking, if you really wanted to, you might ask later on if that makes sense. But here's the key thing. Notice under sensor readings queries, one of the items I have is analyze each dimension independently, right? So it's kind of a requirement we've set, as part of our workflow here. So what that means is I want to be able to go ahead and analyze any one of those metrics without having to filter out the others or stuff. So anyway, so you just start to see where we're using both the conceptual data model and the application workflow to start to generate our pseudo tables. Now what we do is now we start to put the fields to this. We start to look at not only what data do I want to store in each of these tables, but then also, what are my keys? What are the things that will uniquely identify a row? Now, again, I'd like to point out, take a look at the spacecraft journey catalog on the left-hand side. Notice that the fields that you see there, those map really strongly to the properties we had in our conceptual data model, right? It's almost taking the conceptual data model and just implementing it as tables, really. The big difference is what you notice in the nomenclature. So take a look, you'll see these Ks, there are Ks there, and then C. So this is what's called a Chebyshev diagram. It's a way in Cassandra and data modeling we use to map out, some of the logical pieces of my data model. So like, where are my keys? So a K means a partition key. So in Cassandra, when you store something, you're storing it by partitions, right? Now that C is called a clustering column. Clustering columns are used for ordering or uniqueness. So let's break this down what this means. So in the case of the spacecraft journey catalog, what we're saying is that I want to partition by spacecraft name, and then I want to cluster by journey ID. Now, journey ID in this case is a UUID. It's a unique identifier, right? So again, I mentioned before how for an individual spacecraft, I could have multiple journeys, right? So I want some way to uniquely identify them. We're doing that with the journey ID. What this reads as is, for a particular spacecraft journey, if I provide the spacecraft name and the journey ID, I get a unique row. That tells me I'm going to get a unique set of data that then I can pull my start and active and summary fields from, right? So in Cassandra, just like relational databases, by the way, you have a concept of a primary key. What's the purpose of a primary key? It uniquely identifies a row. So spacecraft name and journey ID are going to be the things I'm going to use to uniquely identify a row. Anything else is just data. If you take a look at the right-hand side, and we'll go with spacecraft speed over time, it's the same, by the way. These are all the same. All the metrics, the sensor metrics are pretty much the same, except for the data they store. We're doing the same thing, right? We want to say, well, what fields do I need to include in my primary key to give a unique row? Now, look at this. Its spacecraft name is a K, so it's a partition key. Journey ID is also a K, so we're saying we're partitioning by spacecraft name and journey ID. But now we have reading time that's added in there as a clustering column, right? Now think about what would happen if we didn't put reading time in there. We just had spacecraft name, journey ID, speed, and speed unit. Okay, my spacecraft launches, I record a speed. And now another time step goes and I record another speed. But if I don't have a reading time, if that's not part of my row uniqueness, my key, then I'm just going to overwrite the one that was before it, right? And so on. So I need to insert something in there that's going to ensure that each of the time steps I have is being recorded as a separate row. That's what we're doing here. That's why we added reading time. There's another piece to this. Reading time, this is actually a cool optimization in Cassandra, especially for those of you familiar with relational databases and how they work. So notice the C, again, that means clustering column, and those can be used for ordering and or uniqueness. So in this case, a timestamp, right, we're probably talking about ordering. But notice the arrow, that down arrow, that's saying I want to order in descending order, right? So as new data is coming in, then my data will automatically get ordered on the right, where it's fastest. So later on, when I read the data out, I'm automatically getting the data out in descending time format. I do not need to do an order by. I don't need to pay for that cost at the read. We've already done it at the write. So when you read it, you literally read the block out already ordered. It's a nice little optimization. I'm not going too far into it. That's where you get into like the read and write path. But it's another way that Cassandra optimizes to be able to maintain its performance at scale, no matter how large or small the database is, right? That's one of the key things about Cassandra. Yeah, go ahead, Eric.
And if you think about what actually just happened there, you kind of covered it, but there was this cool little tidbit there. You're actually storing the data in the manner you want it retrieved.
Yes.
Perfectly.
Yes.
So if you think about it, again, from an operator's perspective, or any of our admins out there in the audience, what's happening from an IOPS perspective, since we're actually searching data from an ordered SS table, or grouping of ordered SS tables, we can theoretically accomplish RAIN queries with a single IOP, making it super, super efficient. So the processing to actually retrieve your data is incredibly minimal, and that's why we get such fast read times. That's why you can actually return large blocks of data in like 3 to 7 millisecond P99s. It's really, really powerful because we're actually pre-optimizing the way our data is stored for retrieval.
So I do see a couple questions on YouTube here that I think are really relevant. Himrox, is the data also ordered in descending order based on partitioning key? No, it's based off the clustering column, right? So you'll have a partition. In this case, you'll have a partition by spacecraft name and journey ID. So imagine those two fields, right? Then for that partition, within it, you will have all of the individual rows for the speed, since we're going with that example, right? And it'll be ordered based off of that clustering column, reading time, not the actual partition key.
And I'll throw one other point in there. The partition key, what it actually does, for anyone who's curious, that's actually what controls the data distribution. So what we actually do with the partition key is we hash it and create a tokenized value, and then all of the individual nodes in the cluster own a certain range of tokens, and so that partition will live on whatever nodes have that token ownership. So it's not being ordered by that, but it is being distributed by that.
Yeah. Now, by the way, to be clear, we don't expect everyone who especially is not familiar with Cassandra to understand a lot of the things that we've been talking about in the last 10 minutes. Sure. Because we're having to gloss over a lot because this isn't like an intro to Cassandra course. However, the materials, as a matter of fact, Cedric or Jack or someone who's online, if you wouldn't mind dropping this would be wonderful. We will talk about it here a little bit later, but our datastacks.com/dev site, in there is all of the Cassandra fundamentals. And now it's not just reading, it's actually interactive exercises that you do embedded in your browser. It's all free. They're wonderful. They will give you all of this information. So for those of you who are interested in knowing more about the stuff we've been kind of talking about, totally check those out. Matter of fact, I believe some is for homework actually today. So yeah, you're going to really want to check those out. They're going to go into all the details that we kind of need to gloss over today.
Yeah, so we got a question here, or kind of a confirmation, I think. So each partition stays on a different node. Yeah, I mean, they're distributed. You're not going to really know what partitions are where unless you start looking under the hood. Cassandra handles that all automatically. It does all the hashing automatically. It does the distribution automatically. The only thing you need to worry about is what you're putting inside each partition. So essentially, that primary key construction is your control to data distribution and ordering. So if you can make it so a single query will hit a single partition, then you can make something very, very efficient because it will all be living in one spot. All of the data you're trying to return off a range query will be living in one spot on one node, will be retrievable in the ordered manner from that node. Again, super, super efficient if you construct your primary key correctly.
And Kartik, I see that Cedric gave you an answer to your, is the partition key used for sharding? He already answered it, but yeah, it's essentially a shard if you think about it. It's really, that's how you're sharding the data.
I hate calling it a shard because that bears its own has its own meanings that drags with it. But yes, it is.
All right. So we should move on. So now we've taken our conceptual data model, our application workflow. We've used that to generate our pseudo tables. Now we're looking at spelling out the logical data model, defining what are our keys, what is our data, right? That's really what we've done here. Right? Keys, what's a unique row, and then what's the data that I want, the payload that I want to go along with that. Now we start mapping that to the physical data model. Now notice all that happened here is I just went from defining what my keys and those relationships might be to now just defining the types. That's it, right? So if you again take a look at the left-hand side, you'll see, okay, spacecraft name is a text type. Journey ID is a time UUID. By the way, time UUID is a cool object. It combines a timestamp and a unique identifier, a UUID. Those are actually really neat. And then I don't think the rest of this is going to be much, of a mystery. Start and end are probably timestamps. Active, whether it is or not, a Boolean makes sense. A summary text. So we're taking the same exact structure we had a moment ago. Now we're just mapping to the fields. And then for the final piece, now we take this end result, the combination of the logical and physical data model, and we use that to generate our CQL DDL, right? DDL, by the way, is data definition language. It's the same in the relational world. These are the type of statements we're going to use to generate our schema, create our tables and such. So you'll see we have this nomenclature, this create table if not exists. Here's my spacecraft journey catalog. This is the actual syntax you're going to use in CQL to do this. The fields match exactly what we had in our logical and physical data models. The same thing with the types. The difference there is in that primary key. So if you remember back in the logical data model here, where we had the Ks and the Cs, again, Ks are partition keys, Cs are clustering columns. Now that tells me when I go to write my CQL, what I need to do. Right? So you'll notice in that primary key field in the bottom, you'll see these parens with spacecraft name. Anything in those parens is a partition key, and then comma, and anything after that's a clustering column. So if you take the spacecraft example here, notice I have spacecraft name K and journey ID C. So, okay, I've got a partition key of spacecraft name and a journey ID is my clustering column. So in my primary key, I'm defining spacecraft name as my partition key, comma, journey ID says clustering column. And then I'm telling it the order with clustering order by, I'm saying, okay, I want you to order my clustering column, journey ID descending. If I take the example of, go ahead.
Yeah, I was just going to say, and if you think about what this is actually doing from a how your data will look perspective, that means everything pertaining to that spacecraft name in that table will be within that partition and will live on the same node.
Yeah. Oh, by the way, I see a question from Shatan in Discord. Why not have ANSI SQL? Guess what? CQL is actually a subset of SQL. So you'll find that the language looks exactly the same. There are some differences here and there in how you manage the database and such.
Yeah, for sure. We don't do joins. We don't do some of the other stuff that you would expect from CQL, but it is very, very similar. You should feel very at home with the syntax.
Yes, if you're familiar with SQL, you'll be familiar with CQL. Himrox, the answer to that, it's not clustering query language, it's Cassandra query language is what it is. Yeah. There you go. Okay, so in the second example here, now we're taking our spacecraft speed over time. Again, it's the same deal, right? Where we have the same fields and types that we identified in our logical and physical data models. Notice that primary key though, right? Remember, in the case of the spacecraft speed over time, we had both spacecraft name and journey ID were partition keys, with reading time as a clustering column. So when I get my DDL, notice that spacecraft name and journey ID are in the parens, comma, whatever comes after that is a clustering column, reading time. We're then telling it with clustering order by, reading time, descending order. So this right here alone is enough that no matter what order my data comes in or anything based off that reading time, it will automatically be ordered by the reading time. Okay, and then one thing is kind of like a little special deal. It's called a UDT, a user-defined type. So UDTs are really good for objects that themselves have multiple properties that you're intending to reuse a lot. An address is a great example of this, right? An address has what? It has a street, a city, a state, a zip code, a country. It may have other things depending on what other countries you're in. But you know that it's probably going to be the same properties for any address. And there's a good chance that if you have multiple tables that use address, you don't want to repeat all those fields in every single one of those tables. A UDT is a really great use case for that. So in this case, instead of address, we're using it for location for XYZ coordinates. Why? Because we're going to be using it in multiple places, and all of those locations are going to look identical with the underlying properties that they have. The example here is in spacecraft location over time. Notice if you look down about, say, 3/4 of the way down the fields here, you're going to see location frozen, location UDT. So what we're saying is we're creating a type called location UDT that has X, Y, and Z coordinates. And then when we create our table, we're referencing that location UDT as a type. So there's going to be a location field that has location UDT as a type, which means that it now will have access to X, Y, and Z coordinates. And I don't have to then create X, Y, and Z coordinates for every single one of the tables I want to use. I just use I create one single UDT and I apply that across the board. Okay, so with that, moving on to the next part. So that was the general overview, right? Going from a use case to our data model, and then how we use that to generate the data model. So in this next part, we're going to look a little bit more at Astra, and then creating our schema. So Astra, we already kind of talked about it, right? It is a fully managed cloud-based Cassandra. That's really what it is, right? So where if you were to use Apache Cassandra on your own, you would have to maintain and operate and administrate that database. In the case of Astra, you spin it up through the interface. All of that is being done for you. You literally just tell it key pieces of information like, what do you want to call it, the username and password, and go, right? All of the rest of it's being managed for you. What we're going to use today is the free tier. It's free forever. There's no obligation, nothing like that. It's a 5 gig free tier. You can delete and create and do stuff at your heart's content, and wonderful. There are, though, if you want to go, the free tier is going to be at one end, right? But then there's enterprise class stuff at the other. So if you really want to, beef it up and you want to go production level stuff, Astra does have that as well. But again, to be clear, we're going to be focusing on the free tier today. We don't intend to have everybody, trying to charge up credit cards or anything,
right?
Or anything like that. Okay.
We do have a couple questions popping up here. Is there a 30-second explanation of multi-key primary key for those of us who think primary key
composites? Yeah.
Primary key as always being a single column. Yeah, absolutely. So a partition key that uses multiple columns, essentially all that's happening there is we're adding those two columns together and hashing that resulting value to get the token range ownership, where that thing is going to live, where the partition is going to live. So there's nothing really magical about it. It's really just providing an extra layer of uniqueness by taking two values instead of one. I hope that answers the question. Let me know if that didn't. And then there was another one. Where was it? Here. Okay. Oh yeah, there it is. Can it? I'm assuming this is in relation to UDTs. Can it store an array or JSON? The data type like double, int, etc. So there is a blob type, but you should be a little bit careful with just kind of throwing things into it. You're not going to have parsable JSON like a document store, for example. That's just not what Cassandra is really there for. There is a way to do some stuff through Stargate. If you've played with Stargate at all, it's essentially an API layer. What would you call it, David?
Stargate's an API. That's fair.
Yeah, it's an API layer that allows for a lot of, complex expanded query options. So it'll allow you to essentially use Cassandra as a document store, or play with some other things that Cassandra wouldn't normally do natively. But by and large, you can store blobs, but you're not going to be querying off of an array or anything like that. You have to return the whole array and then parse it in your code. It's doable, and depending on your use case, might work. But
Okay, so just a couple more things about Astra itself. So other than being a managed Cassandra, what else does it provide, right? If you look at the left-hand side, you see those dev tools there. So more than just, okay, here's the database and do something with it, right? There's a CQL console embedded. There's REST and GraphQL APIs that Eric was actually just kind of alluding to a second ago. So you don't only have to use the drivers like what we're doing today. You can actually do things through REST and GraphQL. Yeah. There's DataStax Studio that's embedded. So if you want a nice Jupyter Notebook-like interface, a graphical interface that you can use to execute queries, store like an engineering notebook, share with your colleagues or whatever, you can totally do that. There's a data loader that allows you to bulk load data in. It is also multi-cloud. It is supported across AWS, Azure, and Google Cloud. You'll find today on the free tier, though, the only option you're allowed on the free tier is Google Cloud. Once you start getting to the other tiers, the rest open up for you. But that's just something special with the way the free tier works. And then there are a whole set of ops tools there as well, right? So we're not really getting into a lot of those today, but like the service broker is one to use with Kubernetes, right? There's metrics that are embedded. There's already authentication for you and stuff. So we're going to talk about some of this, but there's a lot more to it. It's not just throw up the database and you're on your own kind of deal.
Yeah, absolutely.
Okay, so for the hands-on, let's get into the hands-on. Yeah. So if you haven't already done it, now is probably a good time to go to datastax.io/workshop. I know we dropped those links earlier. We should probably drop them again real quick just to make sure. Now, for those of you who are joining us again, you've been with us before. If you have an existing Astra database, you do not need to delete it. All you have to do when we go through the exercises is add a new key space, right? We can, matter of fact, Eric, when we do that, we should probably show that.
Yeah, I'll point it out.
It's really easy. You literally click the add key space button, just add the name of the key space, and that's it. You're done, right? So it's not hard to do. Just take note that we're asking everybody to use the default key space username and password values if you're creating a new database. If you had an existing database, those are obviously going to be a little different. There's a step in the exercises later on where you're going to need to update the configuration to ensure that you're pointing to the right key space, username, and password. Just take note that if you had an existing database and you added a key space, you need to use your values, not the values here. Right. You probably won't be able to connect.
And I'll point that out as we go along for sure.
Yeah. We'll definitely do that. The last thing is that download that Secure Connect bundle. Again, we'll go through this in the exercises. The Secure Connect bundle is actually kind of like an unsung hero, in my opinion. If you imagine, we have a lot of Java developers who are on here. I'd love to see a thumbs up or something from all of you that have had fun implementing SSL with Java, because it's not fun at all, right? So what we've done is, as part of Astra, you get, per your database, what's called a Secure Connect bundle. You just download it. It has all the artifacts and everything you need for full encryption between your application and the database, right? Because if you think about it, these are cloud databases. You don't want to sit there and just have like open IPs or anything. All the information you need as far as where the database is and everything is all contained in that Secure Connect bundle. So what this does for you, because the drivers recognize the Secure Connect bundle, it's really easy. It allows you to just say, point to the Secure Connect bundle, give it your username and password, and that's all you need to worry about. The rest of the driver handles the rest for you, including the secure encrypted connection. So that means none of us have to write any SSL code to talk to the database, which is awesome if you've ever done it. Anyway, all right. So with that, the first hands-on exercise, we're actually, if you haven't done it already, we're going to go ahead and create your Astra database. And that, like I said, it should only take a minute or two. Then you will create the schema. So the schema that we talked about earlier that we've generated for you, you'll take that, you'll create that schema in the CQL console within Astra, and then you'll have the base schema that you need to get going with the rest of the workshop. And with that, Mr. Eric, you ready for me to
share my screen here?
All right,
for you?
You are, whether you're ready or not, your screen is now shared.
Oh, yeah.
So I shared it for you.
All right. There we go. Okay, so first thing we're going to do here, I'm going to link this GitHub for everyone again. This is the place where all the resources we're going to use today are living. So definitely make sure you navigate there. I'm actually going to follow the GitHub as well and show you kind of what steps I'm on, try to take you through it. If you get stuck on anything, there's a table of contents there. You'll be able to navigate through up and down. It's all done via the READMEs. So you'll see here we have actually.
I lost Eric. Did I lose everybody?
And then
hey, Eric, just so you know, you dropped off just for a second. So anything you said in the last 10 seconds got dropped. If you wouldn't mind repeating it.
Okay, yeah, I can go back. So we have our table of contents here, so you can navigate up and down if you get stuck or anything. Navigate to the steps you missed. We also have these sections are clearly defined with the different steps. Green check marks denote steps. Pretty simple, and I'll take you through it. So don't worry. If you have any questions, ask. We have people monitoring the chat. Let's all do this. All right. So first thing we're actually going to do is we are going to go ahead, and I'm going to open in a new tab here and click on that guy right there. That is going to bring us to Astra. If you haven't already gone there and created your account, please do so now. I am going to actually, oops, I don't want to sign up because I already have an account. So I'm going to go ahead and I'm going to click sign in. And that is going to bring me to the sign in page, or actually just sign me in because I signed in earlier. Shh, don't tell anyone. And I'm going to go ahead here and I'm going to select the free option. Now, you're not going to be required to put in a credit card. If you select the free option, don't select serverless, just select free. This is a persistent database, free forever, 5 GB data. It's yours. So go ahead and select that. Then we're going to go down here. I'm going to select Google Cloud. I suggest you do as well. That's just the provider that this database will live on. So you'll see there's AWS and Azure are also options there. Google Cloud is just easy for today. All right, and then since I am in the US, I'm going to choose US East as my region. That's the most closest geolocated region to me. If you're in Europe or Asia, I believe Europe West is the closest we have currently available for you. So go ahead and click that. And then just right up here, we're going to hit Configure Database. Now, this is the step where all those values David was talking about need to be put in. So I'm going to go ahead and I'm going to go back to the GitHub repo, and I am going to pull those exact values. So let's go here. Database name is already going to be, here we go. There we go. Database name, my Astra cluster. And we're going to have spacecraft is going to be the key space name, boom. And then we are going to take suser, or our user, and we're super secure here. We are actually showing everyone the password, but don't worry, these are not going to live very long. So, or mine isn't. All right, so go ahead and click Create Database. And that will go and bring us to the databases panel here. Boom. All right, there we are. All right, so we see this card right here. This is essentially my database. What this is going to do for me, in just a moment here, it's going to show up with a pending status. Give it a moment. Man, that mechanical keyboard there, David.
Oh, man, is it that loud? I didn't realize I was getting picked up.
Yeah, I'm going to go ahead and refresh. It looks like it might have not. Oh, it is just pending. Okay, there we go. Yeah. Status is pending. So this database is working on spinning up. It shouldn't take very long. There's
a minute or two,
like 300 of us who are all spinning these up at once. So we'll see how it goes. But it should basically go active here in just a moment. And then I'll actually go ahead and show you guys. There we go. So what I can do here, I have a few options. I can terminate it. I can launch Studio, which is that notebook style interface David was talking about. We can also do some data loading. We can connect, which we'll do in a moment, and we can park. Now, parking is what you do if you're not going to use your database for a while. It basically saves the data, but spins down the actual compute resource, so your data doesn't go away. Really, really useful if you're actually doing a paid Astra database, but you aren't going to use it for a few weeks. Much lower cost. Okay, so
hey, Eric, real quick. Since you already have a database, I do see at least one person in Pursuit over on YouTube was asking, can you show what to do if you have an existing database to add the key space?
Yeah, I'm going to go ahead here. I clicked on my database card, so that brings me into the database. And then what I'm going to go do is I'm going to scroll down here to where it says key spaces. You'll notice I have my spacecraft database there. I'm going to go ahead and click add, and I'm just going to say data or key space 2. Key space, if I can spell, space 2. And I'm going to go ahead and click save. Now I have 2 key spaces. It's really that simple. So if you already had one from before, just go ahead and create one called spacecraft, and we will keep on moving. Remember, though, that when we do get into the code, you are going to have to change the username and password to connect to your database to whatever from whatever, sorry, excuse me, to whatever the ones you previously had configured are. And you can go through Astra and set those up how you want if you need. Okay, so next thing, we're going to go ahead and we're going to hit connect. Now, connect is going to bring us to this nice documentation page that walks us through everything, all the different drivers, the APIs we have access to. I am going to go ahead here and I'm going to click on Python just because I'm going to be using Python today. It's actually the same exact thing we're going to be doing here if you click Node or any of the other drivers. I'm going to go to Download Bundle, and I click a little drop down there. It brings up the database I have. I'm going to right click on that, and I am going to go down and copy link address. Okay, we can go ahead and click that, and then we're going to go back to GitHub. And since we have that copied, we've actually gone through all of the steps here, and we're going to go down to the very, where is it here? Where's the button? Did we get rid of the button for Gitpod, David?
No, it's in the actual.
Oh, it's the bottom.
Yeah.
I'm getting ahead.
Yeah, you're getting ahead of yourself.
I don't follow the instructions step for step. All right. So I'm sorry about that, everyone. I'm getting ahead of myself. I'm going to go ahead and click CQL console right up here at the top where there's summary, health, connect, CQL console. This actually brings up a CQL prompt or a Cassandra query language prompt, which will allow me to interact with my database. This should feel the same as any SQL tool, command line tool you've used in the past. I can actually go ahead and I can use spacecraft, and it does have tab autocomplete. So feel free to type in S, hit tab, and it should autocomplete for you. Now what this has done is set the context for me. So I am now in the spacecraft key space. If I wanted to use that second key space I had created, which was key space 2, I could do use key space 2, and now you'll notice in the little prompt there, we can see which context I was in. For right now, though, I do need to use spacecraft, because that's what we're going to be working with here today. Okay, so next thing we actually have to do is we have to get some schema here. So we actually have provided the schema for you. All of these DDL statements are essentially what we're going to use today. So I'm actually just going to copy paste right into the CQL console there. And we'll give that a moment to complete. And it will complete in just a second. There we go. Okay, and what I can do to make sure that those statements worked is I can actually run a describe command. So let's go ahead, describe. Let's just describe this key space. So spacecraft. And it spits out a whole bunch of different table definitions. Now these are the tables we just created. It's important to note there's this kind of huge blob of stuff at the end of all these table definitions right here where it says additional write policy and all these things. Don't worry about that for today. That's if you're an operator and you want to do some like really fine tuning crazy stuff that not with the defaults, that's where you actually see a lot of your tuning that you had done. Don't worry about that here, though. We are not going to be messing with that. Nothing you need to worry about. The important part right here is basically from the create table statement down to the primary key definition. And, of course, the clustering column is also important there for ordering. Okay, next step. So if we just went and said describe tables, since we're already using the context, it would have spit out the table names. I like to show the actual table structures though, because it kind of makes it a little more real, I think. But there are our table names. We do indeed have the tables we were trying to create. All right, this is where it gets cool. So go ahead and right click. I'm going to right click, open a new tab on Gitpod. This Gitpod button will essentially preload. It logged me out. Let us continue. Give me just a moment here while I get logged back in. Wow, it is making me go through all the steps. Did I get deauthorized? One moment here. Well, it thinks and loading. Okay, so initializing workspace. So what this is essentially a in-browser IDE. It's actually based, I think, on the same code base as VS Code. So it's going to feel and look almost exactly the same as VS Code, but it's going to be running in my browser. It's going to be preloaded with my project, which there we go. All right, so we see the project there. We can even go to that README I was just in, and we can see the raw text. So very, very cool here. We can just click a button. I'm already ready to go with my IDE. Boom, done. All right. So I'm going to go into the Python here and just take a look at what we have here. We have DB connection. Now, DB connection is a very important place where we're going to, if you had used a different key space and had to make a new one, like you had a key space previously created and you had to make a new one, this is where you will actually go ahead and change your username and password to whatever they were before. So just pointing that out here, definitely key space will stay the same because you should have just created a new key space, but DB connection, if you in the Python, is where you'll create that, and I believe DB connection JS in the JavaScript. All right, moving on. I'm going to go ahead and click here on the I decided to use Python tab. Now, what that does for us is that's going to give me a README that's specific to Python. There should be a close parallel to everything. You should be able to follow the Node.js if you prefer Node.js. Feel free to go through it. No worries at all. I'm just going to go through Python because that is my language.
Hey, Eric,
of choice
before
here.
you do that, though,
Yes.
I think we have a couple questions, and then we do have some other materials to go through before we get into that part.
Absolutely.
So let's see. I did see one here. Where did it go? Oh, yeah. Layla was asking, can you please show us the use command again? Maybe you could go back over real quick
Absolutely.
what you did there in the CQL console. And to point out, everything that Eric is doing is in the GitHub repository. So there's no command or anything that you're going to get today that we're just expecting you to follow Eric and like somehow magically copy off his screen. It is all in the README. So if you're following along in that README, you should have the commands there.
Yeah, we also have a question, how to upload Secure Connect bundle to Gitpod. We will get there. Don't worry. We will do that in just a couple minutes here. All right, so the use command, I'm just going to type in use. I'm going to type in this case, key space 2, because that's my second key space here. And again, on the prompt there, you'll notice it says token at CQL blah, blah, blah. Then it has that context there where it says key space 2. That tells me what key space I'm working with currently. Essentially, it's just setting a namespace or a context. So pretty simple. I'm going to go ahead and switch back to spacecraft. There we go. And I'm back in my spacecraft context. Hopefully that answered the question. David, I think you had a couple slides to present or some such.
Yeah, so let's go ahead and, well, I want to give folks a moment. I do see there are just a couple folks that still have databases that are initializing. For the rest of you, if you can give us a thumbs up, let us know that you've got your database, you're good to go, you've been able to follow along with Eric and create those tables. And while we do that for a second, Himrox, is Keyspace the same as schema in a relational database? Yeah, pretty much. A schema or a database in a relational database is equivalent. It's pretty close.
Yeah, it's a bucket that stores tables. So yeah, very similar.
Yeah, and I just saw a comment, will we be able to research this lecture? Should we have trouble catching up? Totally. Everything that we're doing today is not only recorded, it will be on YouTube at the same link that you're using to watch right now. But this GitHub repository, everything, it's all meant to be self-service, right? So if you're not able to keep up for now, that's totally cool. You can just follow up. There will actually be a little homework as well. And this is the key of where that Discord channel comes into play. Because if you have follow-up questions, if you run into trouble, if you're just curious about stuff, that's a great place to ask, is in the Discord channel, because then you'll be able to hit us anytime.
Right.
Okay, let's see. I'm seeing some thumbs up come in.
Says initializing. Yep, there's a few that have initializing still. That's okay. It shouldn't take too long. We should be there before we actually hit the step where we're having to use it. So
yeah, usually it only takes a couple minutes, but I wonder with everybody at the same time, it could take up to about 10. With everyone doing it at the same time, that could just be taking a little bit longer for a couple folks. But I am asking the team to take a look just to make sure, for those that are initializing, that it's all good. So I would say, yeah, just like Eric said, be patient, and we will. Yeah, that's right. Yeah, we'll move on, and I have a hunch that by the time that a lot of you are still seeing the initializing as we move on, they should clear up. Okay, interesting. And you know something, for some of you who are seeing that initializing, try refreshing your browser. I'm kind of curious.
That would be kind of funny, wouldn't it?
Yeah.
Okay.
An improper use command. That's interesting.
I am not sure on that one. If you can post what you're seeing, that would be helpful. The session ends.
Lamano is already did it every 10 seconds. That's funny.
Yeah. All right, we're getting some more thumbs up.
Okay. All right. Well, while we're waiting for that, let me go ahead and just go through a little bit more of the. Okay. So I'm seeing the same thing. The refresh is not changing anything. Now it's active. So one of them that was trying to initialize for the last couple of minutes, just like the rest of you, did go active. So I think part of it might just be with so many doing it all at the same time. It might just be taking a little bit longer. Again, these are free tier. These are definitely on the lower commodity end.
No SLA guarantee.
Yeah, right. It's when you get into the other tiers, a little different. So, all right. So I'm going to take the screen back here real quick, and we'll just let those finish. And I'm just going to talk a little bit more about some of the stuff that we're doing here. So for any of the drivers, and I kind of mentioned this way in the beginning, right? Depending on, if you're using Node or if you're using Python or if you're using Java or whatever, right? The driver teams, I think, have actually done a really bang up job of keeping these as homogeneous as possible, meaning that generally the things that I do in one driver, the type of syntax, nomenclature, and stuff that I use, I should say more nomenclature, will be the same. Right? Obviously, syntax in different programming languages will be different, but the concepts, everything we're going to talk about is the same across the board, generally speaking. So you'll see at the top there, these are the current languages that are supported by the official DataStax drivers. We actually opened these up. These are open source last year. They're now one unified set of drivers. I know from talking to some of you that we have some DataStax Enterprise folks on. In the past, you would have had one set for DataStax Enterprise and a different set for open source Cassandra. They're all unified now. So if you have the latest drivers, it shouldn't matter what you're using. You can use Astra, you can use DSE, you can use open source Cassandra. Now, some things to note about the drivers. They do a ton for you right out of the box of things that you just don't have to worry about. Especially if you take a look on the left-hand side under that connectivity heading, right? Things like being token and data center aware, load balancing policies, it's a distributed database. Obviously, I don't want all of my operations going to one node or something like that. I want those to be nicely balanced around my cluster. And there's all sorts of parameters that come into that. Well, guess what? The drivers do that stuff for you. Can you modify how it does it? Yes, you can. But generally speaking, a lot of the defaults are pretty darn good, right? Retry policies. What happens, or reconnection policies? What happens if a node goes down or for some reason a particular operation is timing out or something? The driver has that stuff kind of baked in, right? The connection pooling. This is actually something we're going to talk about later where you only ever want one session object in your app. The reason why is because those session objects actually maintain the connection pools to every one of your nodes. Again, this is stuff you don't have to do. SSL being a big one that we talked about with that secure connect bundle. This is baked into the driver. Authentication, authorization is all there already, right? There are other pieces like paging, asynchronous support, reactive API for those in Java and other languages. There's all sorts of real coolness factors that are part of the drivers as they are. The last thing I'm going to say about that is the drivers they connect to your cluster. They gossip with it, right? They're actually aware of the status of the nodes in your cluster and everything. They optimize, especially if you're using asynchronous queries, which you should be in Cassandra. But they optimize the transactions and everything that are coming across. So anyway, I can't talk enough about the drivers. I never thought I'd actually be so excited about drivers, but they just do an absolute ton for you. Now, to install them, again, the two code languages we're going to use today are Node and Python. It's really simple for both. In Node, you'll say an npm install Cassandra-driver, and Python pip install Cassandra-driver. Now, the cool thing is in Gitpod, we've already installed npm and pip and all that for you, right? All you have to do is issue the commands. Again, you'll do this as part of the exercises, so you don't have to try to type those off the screen. Now, how do you connect?
Absolutely.
Now, if you remember earlier, I mentioned that when you use Astra and you use that Secure Connect bundle, the drivers are aware of the Secure Connect bundle, and they will handle all the connection, everything for you from there. So this is what you're seeing here. Take a look at the top example with Node. You'll see that we're creating a client, right? Node, we call it a client, a new client. And when I initialize that new Cassandra.client, see that cloud secure connect bundle secure.zip. Now, that zip file could be called anything, right? In this example, it's just secure.zip. But that's it. Right there, that one line says, look to the secure connect bundle, and then it is going to handle all of the SSL piece, all of finding your cluster and all of that. The only thing you need to pass in are the credentials, your username and password. In Python, it's a couple extra lines of code just because you have to provide an auth provider and such, but otherwise it's generally the same. Notice one difference is that instead of client, it's session. You'll find in Java, it is also session. So we call it the session object there. But generally speaking, it's the same kind of deal. You point it to your Secure Connect bundle, you pass in the username and password, and go.
Yeah, absolutely.
And as I mentioned a moment ago, the session object is important. You only ever need one of them for your whole application, period, right? The session object is also heavy. It maintains the connection pools to all of your nodes. Imagine if you had 1,000 node cluster, right? You don't want to be creating all of these session objects. Also, it maintains metadata for your cluster. So the information about your cluster, right? And it's also maintaining what's called the control connection. It talks, like I said, it actually talks to your database just like your nodes do, and it maintains the status of your nodes, right? So all this information is being stored in the session object. You only ever need one of these for your application. And you also want to ensure that when you shut down your application, that you're shutting down the session as well. This is just good practice. It ensures that any open sockets or something are closed, right? You don't want to leave those hanging or anything like that. And again, you'll see this in the examples. You'll see this as we go through the exercises. Okay, so with that, Mr. Eric, I'll give back over to you. We should probably check in some folks. I can do that in the chats. But now we're going to go through the part where you're going to go ahead, you've already spun up Gitpod. If not, you will. You'll install the drivers. You're going to pull that Secure Connect bundle out of Astra and get the plumbing going and test your connection.
Yeah, so let's check chats real quick. We do have a minute or two, I think, where we can do it. We can access recordings after the live session. Yes, you may. We have them all on YouTube. So as soon as we're done here, it basically uploads to YouTube, and then you have full access to it. Let's see, is already downloaded. Is the secure driver bundle already downloaded for us in Gitpod? No, we're actually going to go through that step. We're going to go ahead and we're going to curl it.
Yeah, because those Secure Connect bundles are unique to your database, right? So at the point that we launched the Gitpod, we wouldn't have that information. You need to go into Astra to get that.
Now, I will say there is I think it's a brand new feature in Astra where you can actually launch Gitpod through Astra and have everything pre-configured for you and then build your project from that side.
Yeah, there are code examples in there that let you do that, yeah. Right,
but that's not what we're using today. So, okay, let's see here. I think we're good. Can you delete your Astra account if you signed in? Why would you want to delete Astra? I'm not sure. I've never tried to delete an Astra account. That would be one. If any of the guys in chat there, if you know the answer to that one, you can follow up.
Let's see.
That would be handy. Okay. All right. I'm going to jump in here then.
Oh, I know what.
Start.
Yeah, I know what Hazel's referring to. I'll take that one.
Okay. Absolutely. All right. So hands-on portion. Let's get into this here. So we're going to go ahead and we're going to do exactly what I got ahead of myself and did the first time, where we're going to go into our database. I'm going to hit summary. Now I can either click this connect button up here, or I can click this connect down here. They both go to the same place. It's just, redundant buttons. So I'm going to go ahead. I'm going to click on Python, click the drop down, right click on the cluster, copy link address. Now I need to do this again because if I didn't do it again, I would actually, that link times out after a little bit of time. So the one I copied before would probably not be active if I tried to do it now. Okay, I'm also going to go ahead and close a couple things that I'm not using here. All right. So next we're going to go and we're going to find the curl command. Now the curl command is right here. You'll notice that we basically have it all laid out. There's quotes in there. Those quotes are important. If you copy that command and you delete the quotes, this command will not work. So what I'm actually going to do, just so I can kind of show everyone here, is I'm going to go ahead and I'm going to create, I didn't want to create a new tab. I want to create file, new file, and I'm just going to call it, we'll just call it curl.sh. Not actually going to run it as a script file, but hey, I don't want it there. I want it in my Python because that's where I'm working. And I'm going to go ahead and I'm going to paste my URL. I'm going to also copy my curl command here, and I'm just going to do a quick edit, essentially. So I got both of the parts. Makes it really easy. Boom. I'm going to get rid of your bundle here because that should be what is up above. And we will paste. Okay, so that's my curl command. I'm going to go ahead and just copy that here. Now, you'll notice it's curl-l, quote, the URL I copied, end quote. Oops, did I get an extra character in there? It looks like I might have. Signature. Yes, I do have an extra character in there, so I better fix that. One moment, please. If it works, it just froze on me. Uh-oh, that's not good. All right, and we will try this again a second time. Okay, let's go ahead and boom. There we go. Make sure you don't have a space after your URL. That it is not happy if you do.
And to be clear, right, that URL that he pasted in was the one that he got from right-clicking on his Secure Connect bundle and saying copy link address, right? It's very key that you use that.
Yes, unique to me. So what we did there is we basically just downloaded the Secure Connect bundle. Now, do we actually have it show up anymore? Looking for it here. David, do you know where this? Oh, there it is. I found it. Yep. Okay. So I got my crez.zip. I'm not going to actually open it. I don't want to unpack it. The driver is going to go ahead and consume that. So no worries. Nothing more I need to do. It should be all ready to go. And you'll notice if I check my DB connection, I can go into Workshop, the whole path, and it actually references that file here. So if I were working with a different project, different database, that's how I would specify where my Secure Connect bundle is in this file. I'm just setting a variable and then calling it when I actually initialize the driver. Okay, next step. So connect your application to Cassandra. This is that pip install, or if you were using a Node, you're going to do your npm install. This is that one that David was talking about earlier. I'm just going to go here, and I'm going to pip install Cassandra-driver. Boom, done. It worked. We are actually, requirement is already satisfied. Did we, I think we already actually installed the drivers for him, David. Might have got there.
It might be. That's fine. But I didn't see your screen because I wasn't watching you there.
Yeah. No worries. I'll take it personally. Okay. So now we're actually going to go ahead and we're going to start running some operations. Now, the first one, I'm going to show you these files, and then we're going to run these files. In the README, we don't actually dive into the files, but I do want to talk about them a little bit because it is kind of important. All we're doing here is we are checking our connection. We're basically running a simple select from system local. Now, system local is a piece of Cassandra that is always going to be there. It is an operational table. It's not something you should ever write to manually, but we can obviously select something from it. So that should work. So I'm going to go ahead and I'm going to run Python and then reference that file there. Am I not in the right directory? PWD real quick. PWD. Yeah, I need to change the directory. So you are going to need to run CD into the directory you want to go into. So I need to go into CRUD. Let's see, CRUD Python, and then I should be able to run that same command again. And there it is. Start exercise. Boom. Success. And then it closes the connection because, again, you want to close your connections when you...
And that's it, right? That just proved, right, that basic thing when you get that message back that you are now connected to the cluster that just says, okay, the basic plumbing is there. You've hooked up, right? So that's where we want to get to right now.
Right. The next thing, we've got our insert journey. Now, a journey, as we talked about before, we were using this kind of spacecraft app, right? So kind of a mega IoT app. We're going to just start a journey. That's basically inserting one, setting its value to probably active. And we can actually see here, we've got our spacecraft name, we've got a journey ID, we've got active, we're actually setting that to false. And then our summary is we're bringing astronauts to the International Space Station. Pretty simple. So I'm going to go ahead and I am going to Python exercise 03 insert journey and starting exercise and boom, success. Now, we don't say to do this in the README, but I'm going to do this just because I want to illustrate something. So I'm going to go back into Astra. You don't need to follow along with this step at all. This is just, again, me illustrating something for you guys. I'm going to go ahead and click My Cluster. I'm going to go ahead and click on CQL Console. Notice I'm logged in. I'm going to use spacecraft, and I'm going to just do a select star from Journey. Is it Spacecraft Journeys? I think Spacecraft. Oh, where is it? Journey Catalog. That's what it's called. Spacecraft Journey Catalog. And there it is. That data I just inserted using Python is now referenceable from my CQL console. So just trying to illustrate again, we're not doing any cooking show hand waviness. We're actually inserting data. We're going to be pulling data out. We're going to be modifying data. This is actually happening in real time. All right, going back to it here. So exercise number 4. Now, David, stop me if I get ahead of you if you have any more slides, because
you're already ahead. But that's okay. You're right there. It's okay. It's okay. Yeah.
Okay.
Yeah, no worries.
Yeah.
Matter of fact, I want to see if let's see. I was just checking for a couple in the chats. Right, and there are some questions that are coming through here. Let's see.
Okay, let's...
Yeah, so Shipal asked what to do after the creation of tables. At this point, not much, right? At the next sections, and that's where we're going to get into when you're creating and updating the records and reading the results and all that. So we should be good from that standpoint. Okay, so hopefully folks are at a point where you've gotten to what Eric just did, right? Where he was able to make the connection to the database, and you see that connected to cluster CAS cluster, because that tells you the plumbing is in place, right? So then the next section we're popping over to here is section 4. You should see here for the create and the update records. So just a couple things. Once you have established that connection, again, whether in Node you're using the client object or in Python you're using the session object, right? Each one of those work the same way. You'll notice that if I want to execute a query, I'll just say .execute, and then I'll pass in the query. Now this is the most basic way of doing things. Matter of fact, this is actually a level up from the most basic, because it is using a placeholder question mark variable there in the one case where you pass that in. You could even just paste in a query directly. Would you ever really want to do this in real code?
No. That's not instruction safe.
Yeah, that's not very safe at all, right? Because then somebody could, if somebody were to hack your code and they could inject something in there, they could essentially execute whatever they wanted, right? So that's generally an anti-pattern and why we don't show it here. But the point being is at the very, very basic level, you could just say session.execute, pass in the actual query and go, right? That would be the simplest thing to do. Now, there are some things, especially when dealing with Cassandra, it's not really optimized for the types of use or the what you would expect in Cassandra. In Cassandra, I know that I have a database that can handle many, many thousands of operations per second per node, right? So there are ways to optimize your queries to make them much more performant, especially for subsequent runs, right? And that's really where prepared statements come into play. By the way, this is also the same if you're using a relational database, right? So if you are working with a database and you're not using prepared statements, I don't care what language it is or what database, generally you should be. Here's the difference. In the case of a simple statement, when you execute the statement, it has to be parsed and compiled. That data has to be sent over to the node that's going to run it and all that kind of deal. In a prepared statement, the only difference is that you only prepare and compile once, right? Parse and compile, once. And then you store that. It actually gets stored up on the node. At that point, from a payload standpoint, the only thing that's sent over are the actual data for the parameters that you're sending in, right? It is extreme optimization, especially when you're dealing with thousands of operations. Can you imagine if you had a single query that's being executed thousands of times per second per node? Right? The amount of overhead that causes, right? So that's why you really want to prepare your statements. How do you prepare a statement? You create your statement in a query, whether it is in a query variable like you see in Node. You don't have to call it query. You can call it whatever you want. But you just create a statement, in a variable that stores that statement. You pass that to client.execute, and then you just tell it it's prepared true. That's it. Right? Now, again, you'll find in the different languages, this is one of those cases where the concept is the same regardless of the language, but the syntax might be slightly different. Where a Node...
What's syntax here, to be honest?
Say
Oh,
again?
I prefer the Python syntax because it's very. I think it illustrates
It's just
actually what's going on here.
Yeah, it's just
Where-
different. The Java looks very similar. Yeah, it's just a difference in the different languages and how they're implemented. That's all, right? But all it really comes down to is in Node, you'll see that in your client.execute, you pass the query, you pass whatever parameters, and you just tell it prepare is true. That's it, right? In the case of Python, which I agree with Eric, it's a little simpler. You just say session.prepare, and you pass the query. And then when you go to execute it, you pass that prepared object into the .execute with whatever the parameters are, and that's it. That is enough right there to get you a solid optimization and prepare your queries. Okay, with that, Eric, please continue.
All right, let's go. All right, so we already inserted some data. We were using, if you'll notice, a simple statement. And I'll actually jump back to that file real quick. So we ran, where is it here? Session execute, there it is. Insert, and we basically just threw some values in there. Again, not injection safe. If I had on my website, if I had a field where I took user input and I just tied that to a variable here and ran this query, I could run some, 1=1 style old school injection attacks and probably actually breach something. So don't do that. Cassandra is like any other database. There are the same issues you need to worry about around injection safety and sanitization of data and all of those things. Prepared statements are the way to use them. Sanitize your data, use prepared statements, like David was saying. Okay, let's do takeoff. And which step do I need to stop on, David? So I don't get ahead of you here.
Yeah, you're doing 3 and 4 right now.
3 and 4, perfect. All right, so let's go ahead and let's take a look at 4. Now this is where we're actually going to do takeoff. So we're going to change this upcoming mission to an active mission. And what we're doing here, if you'll notice, we have this update query. We've actually defined the query. So use spacecraft, update spacecraft journey catalog, set active equals true. We're basically just doing an update on that statement we previously had inserted. You'll notice here that I have this prepared update connection session prepare update query. So the query we defined up top, we're just doing a prepare. Again, that session, since we're in Python, we're using session instead of client. We're doing session.prepare. We're preparing that statement. So it's being compiled. And all we're going to do when we execute that is we're going to send the statement ID. So it gets an ID between the driver and then the actual database itself. We're going to send that statement ID and then the payload of the data. So whatever data we wanted to send with it gets sent essentially as a payload and then applied to that pre-prepared statement. Okay, so then we do a connection, session execute, prepared update, so that prepared statement, and then we list off the values there. So date time now, so we're actually using the now function that is actually a Python thing, spacecraft name, which we've defined up here, so yeah, we've got that there. We've got journey ID, which is a UUID, which we've defined statically here, but we could also have generated that as, this is going to be the unique journey ID, and we can use a UUID library to actually generate that. Okay, so I'm going to go ahead, and I'm going to Python example for takeoff.py. So go ahead here and success. Now, I do want to just show you guys again, just so we can see that there's no hand waviness. Actually, I'm just going to select star from spacecraft journey catalog. And we're going to go ahead and see that, look, we have now changed the values from before. It was set active equals false. It's now set to true. We have a spacecraft name. The journey ID is there. All of those things that were not there in our original insert are now in the database. So we went and we performed an update. So we have now done a C and a U of the CRUD operation acronym. We have 2 more to go, and then we'll get into some other cool stuff. All right, David, I think back to you.
Yeah, okay, great. I'm going to just finishing up answering something here. All right, let's go ahead and pop back over.
Perfect.
Yeah, I'm just doing a quick time check. Okay, wonderful. All right, so hopefully, hopefully you guys were able to kind of follow along with Eric. Again, if you do get a little behind, it's no big deal. All of this is meant to be self-service, and you can always follow up with us. So now going into the next sections with 3 and 4, you said you just brought them through 4, right?
4, yeah.
Okay. So one of the concepts in Cassandra that you should be aware of is something called a batch. Now, a batch is not for bulk loading data into Cassandra, right? So if you come from the relational world, you're used to batch statements and doing them and using them that way. That is not what we do with them in Cassandra. What they are for is keeping multiple denormalized tables in sync. So what did that just mean? Well, Eric kind of alluded to this way in the beginning when we were talking about the data model. And if you remember, when we had our sensor metrics table, right? Like speed, temperature, pressure, location, all those looked almost the same, right? They had the same keys and everything. The difference, though, was in its data payload. So some might ask, well, how do I, if I have all these tables that are denormalized, how do I keep those in sync when I'm making inserts? The batch is the answer, right? So the batch, really all it's saying is, hey, if I'm going to, like in the example we have here, we're actually inserting into all 4 of our sensor metrics tables at once. All it's really saying is, I'm going, if any one of these fails, I'm going to fail it, but if any one of these completes, then I'm going to guarantee I'm going to complete them all, right? It's just making sure that if you insert into one, you're essentially inserting into all of them. And this isn't something that's some hard requirement. This is something we're saying in our particular data model, in our particular app that we want to do. So again, if you have a set of queries that need to be executed, or inserts or updates that need to be executed against a set of denormalized tables that are all using the same key like we have here, that's a good use for a batch. Batches, by the way, are another place where you definitely want to use prepared statements, and notice that you'll see there that the prepare is true. Now, again, the syntax a little bit different. Like Node actually does it a little bit differently than the others. Python looks a lot more like what you'd see in Java, where you have the dot notation access. So I'm going to say I'm going to create a batch statement in Python and then just say batch.add, and then I'm going to add each of those statements. Now you might be wondering, where's my statement, right? Notice how you have prepared insert location, prepared insert speed, right? These were just prepared statements that were created earlier. So the statements are stored in those objects, prepared insert speed, insert temperature. And then we're just passing the parameters along to it, right? This would be similar to how I do it in Java as well, right? So again, the syntax is slightly different between the two, but the concept is the same. But that's it. That's all you need for a batch. So if you ever have a case where you have a set of denormalized tables, you want to keep them synchronized, you just wrap them in a batch, and that's pretty much it from that standpoint. Now, with UDTs, generally speaking, you don't have to do anything special with them in code, except for Python. but if you're using prepared statements, you don't need to register your UDTs with a cluster instance. But if you're not using prepared statements, you do need to do a little extra bit of work in Python. So to me, kind of the lesson here is prepare your statements, right? And you might ask, well, when won't you prepare? If you truly have a query that's only executed once, you don't really need to prepare it, right? But if you have any query that's ever executed more than once, you need to prepare it. And so really, this is just kind of, an extra bit of info because there is this difference. We're pointing it out to you. You don't absolutely have to do that as long as you're preparing statements. Okay, so with that, go for 5 and 6.
Awesome. All right, let's do it. All right, so 5, let's take a look at what we're actually doing here. Now, remember, we talked about batches. I'm just going to echo something here because I don't think we can say it enough. Batches are not for data loading. They are not a relational batch. It's kind of almost an unfortunate naming because they have literally no parallel. Do not use them the same way you would use them in the relational world. You will end up in a very bad place. Your app will not perform, and you can actually, I've seen people take nodes down doing that. So don't do that. All right. Next, so what we're going to do here, we're going to do our travel. So we're actually going to start collecting data, essentially, or we're going to simulate the collection of data, right? Because all this data is fake. We aren't actually launching a rocket today. That'd be awesome. Anyway, so we've got our prepared statements here. We can see we've got insert into spacecraft speed over time, all the values, insert into temperature over time, pressure over time, location over time. Each of those is becoming a prepared statement. We're preparing them, session prepare, so we're actually doing the compile, essentially, of that, what that statement is. Then we go down here and we have the batch. So batch equals batch statement. Now I could name that batch anything. I could name it, batch 1. I could name it pterodactyl. I could name it pretty much anything I want to name that. We're just using batch here to try to be really, really explicit and clear with what exactly it is we're doing. So batch equals a new batch statement. We're going to add the prepared statement, the values, so the payload to that. And you notice we're actually defining those values. So those aren't just variables. We aren't going to modify them later. We're actually adding the command we want to run, or the operation we want to run, to the batch. We do that with all the location, speed, temperature, and pressure. And then we do a connection session execute. So just like we could execute a single statement or prepared statement, we execute a batch exactly the same way. We just put that execute, and then we put the batch in as the parameter. So let's go ahead here, and we're going to do Python ex05, and that is our travel. We're going to go ahead here and traveling. So we are basically just spoofing a whole bunch of random numbers. You'll notice we have actually some code with random ints up here. So we're just taking random sensor data is all we're doing. And we're just spoofing that, inserting that, and we're running probably, I don't know, is it 1,000 batches? Yeah, 1,000 batches we're going to run here. So, I can kill it before it's done here. That's fine. All right, says failure. It's not actually failed, and I'll actually prove that to you. We can go here. We can do select star from spacecraft. Let's do, what table? Let's do pressure over time. And we can see tons and tons of data in there. And we can see that the random number generator was indeed generating random pressure numbers. Now, if our pressure was fluctuating that extremely, we'd probably end up exploding something. But for purposes of the demo, it makes sense. All right. So next, we're going to look at landing. Now, you'll notice what we've done here, we are not preparing anything or anything like that. We are updating. We are setting this journey to basically no longer active, right? We've landed. We are now at a journey status of false. So let me go ahead here and Python. This is nothing new. This is everything we've done before. So I'm not, that's why I'm not really digging into it here. We're just kind of cleaning out what we did. 06 landing, start exercise. And then I'm going to go ahead and verify in my CQL console. Select. Oops, I am in the. All right, there we go. Select star from. You ever done that where you type commands in the middle of an output?
It wouldn't be the first time.
Yeah. Journey catalog. There we go. Oops. And we'll notice that it is now set. It's active. Is set to false. We have accomplished our mission success. We can all, pop the champagne. We have successfully flown the rocket. So basically all we did there was we just ran an update. Simple as that. Nothing crazy. All right, David, I think we are back to you. Yes, back to you.
All righty. Okay, so all right, so with this last, with the piece that Eric just showed you, right? Now we've actually run through a journey. Maybe you've done another one, and that is going through the process of creating and updating records, right? And again, each one of these snippets that you're running, each one of these executions you're doing, is just a vignette of, okay, I want to, update some data. I want to create some data. I want to use a batch or whatever. So when you're looking for your own references, you know that you've got a piece of working code. You can take a look. They're meant to be very quick and to the point of doing the very operation, from CRUD, right? From create, read, update, and delete. In this next section, now that you've updated and you've created a bunch of data, you've created a spacecraft journey. Now you want to read the results, right? So we want to take a look at what does that look like? Maybe things like if I do a simple select, or if I'm doing, more extensive parsing, or if I want a page. Imagine you have a petabyte database. You probably don't want to be returning the results of all billions of rows in your particular table or something like that, whatever you happen to have. This
you don't have a petabyte of RAM, David? Come
yeah,
on.
right. Yeah. You know, like, but not only that. I mean, I think paging has been around for quite some time. It's very functional, especially imagine e-commerce or something. If you went to Amazon and, you know, something had 1 million results, you don't want to see all 1 million, you just want to see 10 or 50 or whatever it is. The paging is baked right into the drivers. It's really, really simple to use. And especially too in the nature of Cassandra, where it is a distributed asynchronous database. You want to do this right? Well, guess what? The driver does it for you, essentially. You just have to use your paging state. You're going to get an example of that now. And then feel free to go through all through 10.
Oh, perfect. Wonderful. All right. So what we're going to do here, we're going to look at list journeys. Now, I kind of cheated and I showed you this exact thing in the CQL console. That's okay. We're just going to do it manually. And we're actually using a where clause here. Now, you'll notice that we're querying off of spacecraft name. There's an important little thing we didn't really talk about earlier, but where clauses must provide your partition key and any preceding clustering columns. You cannot use a where clause off a data column. That's actually a good thing. It forces us to denormalize and data model correctly. So not actually, you know, when most people get exposed to Cassandra and they instantly try to write a where clause and it doesn't work, they go, oh, this is a terrible database. Actually, no, it's a very, very good thing because it forces you to pre-optimize your data and achieve the kind of speeds that you should be getting from the database. All right. So I'm going to go ahead and I'm going to run this. So Python EX07 list journeys. Now this is just going to list the one because we just have the one. Now if I had gone through and I had, yep, there it is right there, journey, there's the ID, there's the summary. If I had like 12 journeys here, and please experiment with this, go create more journeys. You'll need to change out that little UUID line in the insert, or I think insert journey file. You'll need to just set it to dynamically create a UUID because we had one statically defined, but you can go through and you can literally just create 50 of these and this will list them out. You'll be able to see everything you put in there basically. Okay, let's go to the next one. So in read journey, this is where it gets kind of cool. So what we're doing is we're saying, okay, we know what the ID of that journey is, right? That UUID, we just printed that out right here. We can see what that is. We're going to go ahead and we are going to query based off that. So notice spacecraft name, and we've also added journey ID to our where clause. So that journey ID is now going to return all that information. So I'm going to go ahead here, and I'm going to execute Python EX08 read journey start exercise, and there we go. We got a summary. We got all sorts of information, basically the same stuff we returned from CQL, but obviously formatted nicely because we went into Python and made it format in a nice little report. So we have our ID, we have the spacecraft, we have the summary, the status, landing, takeoff, the times, all that stuff is created for us. Pretty cool. All right, and since we're just going to keep on going, I'm going to go to read metrics. Read metrics is where we actually get to, oop, did it freeze up? There we go. Read metrics, there we go. Read metrics is where we actually get to start looking at some more tables. So the pressure, speed, all of those things, that's where we're going to actually start interacting with those. So I'm going to go ahead, I'm going to run this, and then I'll talk through it, because it's probably a little more clear to do it that way. 0, 9. Read metrics. So we're going to see what it spits out here in just a moment. All of those values from the different lines that we had generated, you remember we had those random number generators, all those values got spit out here. We have the ID, so that's the actual record number, or the identifier was all we were using. We're just using an incrementing number for each individual time we were inserting data. We have the timestamp, which you can see those are indeed ascending, descending. No, ascending, goodness. And then we have our values, which again, were a random number, which with a little bit of logic in there to make it increment correctly. So really, really cool. We're able to print out our data. We would be able to, if we were trying to do some analytics on this stuff and actually look at a journey, a specific journey, and mine it for some data, we could go through and we could query for multiple tables, do any data operations. At this point, personally, being a Python user, I'd probably be using Panda, loading up some data frames and doing all sorts of manipulation on it. But we're at the point where it's now up to you as the language user to go forth and actually use this data. So really, really cool stuff. Last one here, read metrics with paging. Now, paging is exactly what David said it was. Paging allows you to get a subset of the data returned. So if I only want the first 10 results from my table, but then I'm going to want the next 10, then I'm going to want the next 10. For example, if you were on like Netflix and you see the suggested for you panel, and you can click left or right, and it shows you the results from their database query. That's actually what they're doing. They're paging, and they're returning the results from that particular page. So when you click next, it returns the next, whatever, like 4 or 5, 10 results, however many you have displayed there. That's exactly what we're going to be doing here. So let's go ahead and take a look at the code. What I've got is I've got my connection, I've got my query. Okay, so this query is exactly the same as the query from the last one. We're just selecting a spacecraft from spacecraft speed over time, where spacecraft name is one thing, journey ID is one thing. Boom. Our statement, we're just doing a simple statement. We're not doing prepared statements. Obviously, as David said before, please use prepared statements basically everywhere. That's what you should be doing. All right. Then we're going to do, where is it here? Our offset. Output items. I lost my place here. One moment, please. Paging exception. David, where'd it go? Where's my flag? Oh, there it is. Yeah.
Oh, sorry, I wasn't watching your screen, Eric. I'm answering questions over here.
I literally highlighted the thing I was looking for. So what happens when you run a paging query is basically it will return a pointer that then you can resubmit, and it will return the next set. The driver will retrieve the next set of data. So you don't need to store this all in RAM and then iterate through it. You're basically saying, send me the first 10 records, then send me the pointer to where we stopped at, and I'm going to consume those next 10 records, and then I'm going to send back that pointer so you can send me the next 10 records. In this particular case, do we reset? Yeah, fetch size is 10. So fetch size default, I believe, is 2,000. Is it 2,000 or is it 5,000, David? Do you remember?
Default's 5,000, I believe.
5,000, okay. Yeah, so fetch size default 5,000. In this particular case, we're doing 10. And if I were to run this, Python.
Yeah.
EX.
And Cedric just confirmed that too. Yeah, it's 5,000.
Perfect. Oops, 10. Read metrics paging. We are going to then return. We return 10 items. Now, in this particular case, we don't ever resend our query. We don't send that offset back. But if I wanted the next 10 items, I could just write another. I could basically throw a loop in my code here and just have it resend that offset, and I just get my next 10 items, my next 10 items, my next 10 items, and it would work. That's what paging is. It's actually an incredibly powerful tool. It's used in all sorts of places. Once you understand what paging is, you're going to go, just browsing online. You're going to look at things and realize that, oh, my Facebook feed or my Instagram feed is actually using paging as well. You know how it has the show more button at the bottom there? That's actually paging as well. Paging literally is everywhere. Anywhere where you need a subset of data and then you want to show more eventually. It cuts down on load times. It increases efficiency. It is a huge, huge tool. All right. Let's see here. I think I'm basically done. That was section 10, so I'm going to hand it back off to David, and we can get going here.
Alrighty. Excellent. Well, just a couple things to wrap up with everyone today. We always try to keep these in time. I did mention at the very beginning that we were going to give you some resources. I have a couple slides on there. So there are so many of you came in brand new to Cassandra and asking a lot of questions, especially some about the Cassandra fundamentals and data modeling. Go to datastacks.com/dev, this link that you see up here in the top. Absolutely do that. Why? Because there you'll actually be provided with a whole set of coursework that's actually embedded in your browser. It uses a technology called Katacoda. If you've ever used Katacoda, it's from O'Reilly. It's free. It's awesome. So what'll actually happen is you spin one of these things up, and it actually spins up a Cassandra instance for you in the cloud. Why that's cool? Because not everybody has a laptop that can run Cassandra on its own, right? It'll even hook you up to Astra, do all of that. And then you do all the exercises there at your own pace right there in the browser. It is seriously cool stuff. And there's all sorts of, there's a whole set. I'm trying to remember how many there are for the Cassandra fundamentals. But if you want to get those kind of answers like, well, how does replication work? What is consistency level? I saw a question about consistency level earlier. What are all those things? Like, it'll answer all those in the fundamentals. And then in data modeling, right? If you want to go a lot deeper into the stuff we talked about today with data modeling, go there. But there's even more, right? There's Kafka integration. I'm trying to remember some of the other ones I might be forgetting off the top of my head, but there's a ton. So go check it out.
Fun, yeah.
Yeah. And then also separate from Discord, right? We have our community. So if you go to community.datastacks.com, that's a great place. It's like Stack Overflow for Cassandra, right? So not only do you get access to other Cassandra experts, people that are outside of DataStax, people who've been running these things on their own, but it's a great platform for if you've got longer form questions, you need to add some screenshots or whatever, you're looking for, a deeper answer. That's a really great place to go. So sometimes you'll notice that us on Discord, we might point you there on purpose for some questions because it's a better medium for them. We are on YouTube, we're on Twitter, we're on Twitch. Connect with us wherever. We are happy on LinkedIn. Right, we are happy to take your questions, and if you have follow-up or whatever, that's always good to know. Again, the exercises, the workshop itself is at the GitHub repo that's down there in the bottom. And some homework. So you're in fact going to use datastax.com/dev for your homework. So for those of you who are going to join us next week, and please do, right? You should absolutely join us next week because we have more coming for you. Take a look at this stuff. These are some of the courses that we were talking about. Again, this stuff is all free. So you'll see the links there. And these will now get you a little deeper into some of the stuff that we just covered, right? You notice the driver quick starts, getting into CQL, building a REST service, all that stuff is done right there in the website embedded. And then if you're going to come with us for next week, get ready for week 2, then take a look at those links that you see down there at the bottom for Cloud Native and Kubernetes.
Awesome.
All right. And then certifications. So certifications, for those of you who are looking maybe to level up your career a little bit, the Cassandra certifications right now actually can translate into real money, right? There's actually a shortage of people who can administrate and work with Cassandra databases out there. And what's crazy about it is that the demand for Cassandra is very clearly there, right? So getting these certifications is definitely something that you can put on your resume, something you can put out there in the social world, let people know you've done this. What's really cool is that by attending this series, and for those who apply and you register to the 3 episodes that we're going to have, we're going to give you a voucher at the end, right? That voucher is good. The tests normally cost $145 each. The voucher will give you 2 attempts. Now, what that translates into is you could actually say you want to do the developer certification and you pass it. Well, now you have a attempt left over you could use for the admin certification. Or if for some reason you didn't pass it, now you have another attempt free of charge. Right. So this is something we're giving to you as a thank you for coming here with us, and is definitely something that can help level up your game. And what's also neat with that is if you do choose to go down the certification path, again, go to /dev/certifications, you'll actually go through a whole set of coursework on the fundamentals and data modeling and admin and such that will answer all of the questions that you might very well have on Cassandra itself. And with that, thank you so much. I am just the registration link, please. Let's see. Oh, okay. I see Jack just dropped a link.
Had that.
Yes.
Yeah. Jack got that.
Okay. All right. Wonderful. So again, thank you, everybody. Thank you so much for joining us today. We definitely want to see you next week. And again, if you have any follow-up questions or whatever, hit us up in Discord. Come over there, talk to us, or hit us up on community. We'll be watching. So if you do run into any troubles or anything, come let us know. Otherwise, enjoy your database and happy coding. Thank you, everyone.
Later.
And as always, don't forget to click that subscribe button and ring that bell to get notifications for all of our future upcoming workshops.
Imagine a being gifted with powers from the goddess of Cassandra, who grew those powers until she could multiply at will, move with limitless speed, and unmask hidden knowledge. With those powers, she was able to fully understand the connectedness of the world. What she saw was a world in need of understanding. From that day forward, she sought to bestow her powers on all who came into contact with her, empowering them to achieve wondrous feats.